We're going to find the domain of log of x and ln of x for these problem sets 45 through 55 on page 297. What I wanted you to notice, though, is that down here I wrote the domain and range for exponential functions that we did in 4.3. And just notice that they changed because they're inverses. The log and natural log of x are inverses of each other. All we did was change the domain and range with these two. So they're basically flipped here for the domain and range. And we'll see that better when we do the graphing, which is the next video. Okay, so I'm going to do some of the odds. So we're going to do 45. And it's a lot like your square root function. So 45 is f of x equals ln of x minus 3. Okay, so basically we know this part right in here has to be bigger than 0, because that's our domain right there. So here we go. So all we're going to do is set this to 0. Has to be bigger than 0. So solve for x. So x has to be bigger than 3. So it's all real numbers with the restriction that x must be bigger than 3, or greater than 3. Now 47, we have log f of x, they made a big F for some reason, equals log base 2 of x squared. Now, this requires that x squared, this part here is your x, has to be bigger than 0. Again, based on our domain here. So, we just set that to 0. It's bigger than 0. So that's pretty easy. X is bigger than 0. Square both sides. Or square root both sides. So you get x is all real numbers that are bigger than 0. Okay. That are positive, in other words. Okay, 49 is basically the same thing. Log base 5 of x cubed. So we need x cubed to be bigger than 0 for the same reasons. Cube root both sides, and we get x is bigger than 0, so your domain is all positive numbers. And 51, oh boy, it's 49. Oh, I did 48 for you. Lucky you. Alright, so 49. We have, oh my goodness, it's getting harder. So we have f of x equals 3 minus 2 log base 4 of x over 2. Well, the main thing you have to know is this has to be what? Bigger than 0. So that's all, it looks all complicated here. So I'm just going to set this to be greater than 0. Cross multiply, and I get x is bigger than 0, so that's your domain. It looked all scary, but it really wasn't that hard. And let's do 51. Okay, so 51 is where it gets a little more interesting. We have f of x equals ln of 1 over x plus 1. So that requires 1 over x plus 1 to be bigger than 0. Now, what we also know, if I let p of x equal 1 over x plus 1, we know that this is undefined when x equals negative 1. So what I'm going to do is I'm going to do test values here. So I'm going to test intervals. And I'm going to go from negative infinity to negative 1. We know it can't equal negative 1. And we're going to go from negative 1 to infinity. So I'm going to test value, see a test value of negative 2 and 0. So I plug in 0, and I'm also going to do a value of p would be negative 1, and the value of p would be 1 in this case if these are my test values. So the conclusion is this is negative and this is positive. So the domain can't be, so the domain is going to be x, such that x has to be bigger than what? Negative 1. Now let me show you what I did here. I did, since we had a little restriction here, we have a vertical asymptote here, I did test values here. So I tested some number between negative infinity and negative 1. So I tested negative 2. I plugged it in and I got negative 1. We can't have a negative 1 in here. And I also tested 1. So I tested a value between negative 1 and 0. I decided to test 1. It ended up being positive, which we want it to be positive. So that's why I had to pick x is bigger than negative 1. We know it can be 0, because 0 works, but I tested, I tested 0 here, and it works. So it has to be bigger than or equal to negative 1, because 0 works. So that's how I did it there. Okay? Let's do 53. It's going to be the same kind of thing. We have log base 5 of x plus 1 over x, which requires x plus 1 over x to be bigger than 0. So I'm going to let p of x equal x plus 1 over x. So I want to do test values. And right away I know that it is undefined. This is undefined. It's 0 or undefined when x. We can't have this, the issue here is this can't be 0, right? So this is undefined at x equal negative 1 and x equals 0. It's undefined at x equals 0 because you can't divide by 0. It's undefined at negative 1 because you plug in negative 1 here, we get 0 over negative 1. This right here cannot equal 0. It has to be bigger than 0. So we have two issues here, so we're going to do the test value things. So my interval is going to be, I'm going to have my intervals set up. Intervals, I can't spell, that's why it looks funny. Alright, so my intervals are going to be from negative infinity to negative 1. I'm also going to try negative 1 to 0 from here to here. See what happens in between here. And I'm also going to test 0 then to infinity. And I'm just going to pick some values, some test values. I'll try negative 2 here. Don't want to try negative 1 because you know it can't equal 1. I'm going to try negative 1/2, I guess. And I'm going to try 2 here. You could try 1, but I'm going to try 2. And then I'm going to see what the value of p is. So the value of p is 1/2 here, negative 1 here, and at 2 it's going to be, actually I do want to test 1. Change my mind. We'll test 1, and I'm going to get 2 because I already wrote this stuff down. Alright, now, so basically this is positive, so this is the conclusion we have. 1/2 is positive, this is negative, this is positive. So basically we're not using this because we can't have a negative number in there. We need positive numbers. So basically the domain is like this. The domain of G is all real numbers such that x must be less than -1 or x is bigger than 0. So I'm going to go back and show you why. This is where x is less than -1. We can't use this. This is where x is bigger than 0. And that's exactly what I wrote here. Okay? Now, let's do another one. Let's do 55. So 55 is f of x equals square root of ln of x. We know that ln of x has to be bigger than or equal to 0, and x has to be bigger than 0. Alright, so I'm going to solve this. I'm going to let ln of x bigger than or equal to 0. I'm going to multiply this by 1. So I get ln of x is greater than or equal to ln of e to the 0. So these cancel, so you get x is bigger than or equal to e to the 0. And we know anything to the 0 power is 1. So the domain of f of x is x, but x has to be bigger than or equal to 1. Okay? And that's all of this one. The next one is going to be about graphs. And I think that will help you understand the domain and range a little better as well.